Hello, today's topic is promotion. I usually do not have time to discuss this topic, but in this semester I have tried to speak really fast. I tried not to bore you, so we have time to discuss this interesting topic. And by the way, this topic is related to the previous topic, which is incomplete contract, and also I want to say that this is the last lecture of this semester, so I thank you for listening to these lectures and being part of this whole process. Alright, so let's get started. So promotion. Employers want employees to invest in firm-specific human capital. So why is that? So job-specific skills are a key determinant of labor productivity. So if you invest in some job-specific skills, and you will be better in that jobs, and then the overall productivity will be improved. But the problem is the acquiring job specific skill is often costly. You have to learn new things and you have to spend time to get used to that job, and you have to put effort to improve yourself. So it is costly, but it is not appreciated in the market because it is job specific and because it is relationship specific. So this gives rise a holder problem. So what is the holder problem? So we have discussed this. We have seen this holder problem in the previous lecture. So again, let me just repeat this. So when an investment in a skill is not contractable and the skill is relationship specific, then the investment is not made at all, because once this investment is made, then that will undermine the bargaining position of the investor. I mean the relationship investor of this relationship specific investment. So that's the holder problem. That's so you know because it is not appreciated in the market, and once this investment is made, then it will just undermine the bargaining position. So the the worker doesn't have reason to make an investment in this job specific skills. Then the question is, how can we overcome this holder problem? And I already gave you the answer. The answer is using promotion, we can overcome this holder problem, but not perfectly. But still, we can somehow overcome this holder problem. And and this is one way to look at this holder problem. I mean the promotion. Why promotion exists, and one answer is this: to overcome the holder problem. More specifically, in a firm, there are different tasks and jobs which can serve as the basis of contracts. So the starting point of this model is that the performance is not contractable. So in let's go back to the basic principle agent model. There we assume that performance, the output or the revenue, is observable and verifiable. Thus, it is contractable. So we could design a contract which is giving incentive based on the performance, right? So we could think of performance based incentive scheme, or the performance specific incentive scheme. But here we assume that performance is not verifiable. Then how can you overcome this moral hazard problem, right? So how can you give an incentive to the worker to work, right? So that's the problem. So an employer can offer a job specific or task specific wage. So using this position or jobs or task as the basis of contract, the employer can give an incentive to make an investment in this job specific skills. So the promotion is to assign a different job, or oftentimes the job is more difficult or riskier with a higher salary. That's the idea of promotion, and that will give on worker to make an investment in job specific skills or relationship specific skills. So then the question is, why is job specific compensation used instead of performance based compensation? The answer is because performance based compensation is not possible, because we in some situations performance is not verifiable at all. So in that case, and that will be the case in many situations, in many organizations. So instead of giving incentive based on performance, the firm gives incentive based on jobs or tasks. All right, so that's the idea of promotion. So can job specific contract solve the holder problem? So that will be the question that we want to address in this lecture. So let's look at the model. So there is one principal or employer and one agent or the employee. The output X depends on both the agent's talent and skill. So theta is agent's talent, which is a number between 0 and 1, and it is fixed, but it is not observed. And skill is acquirable. So output is function of talent and skill. Talent is fixed, skill is acquirable. And the agent decides whether to make an investment in skill. So if the agent make an investment, then now the skill level becomes 1. So the starting point skill level is 0, and if the agent make an investment, then skill becomes 1, S becomes 1. All right, and both ability, talent, and skill are unverifiable. Thus, it is not contractable. So this is the problem. So in previous and also more importantly, we'll assume that the output is not verifiable. So that's the key problem in this situation. In many situations in reality, in real world, the output or the performance is not verifiable. So in that case, we cannot use performance-based incentive scheme. So then we have to use something like job-specific, job-based incentive scheme. So and the entire system is called promotion. All right. So and even the individual output is unverifiable. So only job-specific or position-specific wages can be offered. So that's the key problem, and we'll see whether even in this situation, even in the situation where the individual output X is unverifiable, we can do something. We can make an employee to make an investment. And let's suppose there are two jobs, E and D. So E stands for easy, D stands for difficult. And output XE and XD, and wages are WE and WD. Okay. So again, notice that now wage is just WE. It's just function of job. It's not a function of X, right? So the wage is not a function of output or performance, because we assume the output or performance is unverifiable. So now the wage is just function of position or job. And now the timeline looks like this. In the first stage, the principal offers job-specific wage, WE and WD. So WE and WD are determined in the first stage, and we'll just take them as given in the later stages. So the agent decides whether to accept the offer or not, and then decides whether to invest in skill S, and agent's talent theta is revealed to both the agent and the principal, which means in previous stages the talent theta is not observed. So nobody knew what theta is. And without knowing theta, the agent decides the skill the agent makes the skill decision, right? And the principal assigns the agent to job E or D, and then the output X is realized, and then wage is given accordingly. So the skill investment is similar, but not the same with the exerting effort. So the skill investment decision is similar to effort decision in basic moral hazard models, but it is not the same. It is not the same in the sense that this is a dynamic game. So let's think about basic principal agent model. In basic principal agent model, uh, after everything is determined, like the wage level and the whether to work for the principal or not, and later the agent decides how much effort to put in the task. But here, the effort decision or investment decision is made before the principal make a allocation of jobs. So the output and the wage levels depend on the principal's job allocation decision. So what that means is this is not the structure of the game is different from the basic principal agent model in the sense that now the principal also has moral hazard problem. What I mean is maybe the principal doesn't want to promote you. You make a that's the source of the holder problem. So what's going on is this. So you make an investment, you make a job specific investment, and so your skill level is higher, but at that point maybe the principal doesn't want to promote you. That is possible, right? So you make an investment expecting that you will be promoted, but the principal deny to promote you, right? So so there is this trust issue, like you have to trust the principal. So there is a double moral hazard problem. So the principal also suffers a moral hazard problem. So the principal may not want to promote you, and then because you expect that the principal may not promote you, so you just do not make an investment at all, right? So that's the holder problem, right? So that's very interesting structure. And let's see these assumptions. So the first assumption is that XD increases faster in talent than XE for any S. For any skill level, XD increases faster in theta than XE. So that's the first assumption. The second assumption is that XD theta 1 minus XD theta 0 is greater than XE theta 1 minus XE theta 0 for all theta. So these are two key assumptions, but they look kind of abstract. So for concreteness, let's consider this very specific example. So we assume that XD theta 1 equals to alpha D plus beta D times theta. So this XD theta 1 increases at the slope of beta D. And XD theta 0 equals to alpha D plus beta D over 2 times theta. So the slope is beta D over 2. So if you make an investment, then the slope of this x function, xd function, it doubles up, right? So if you make an investment, the slope doubles up, And that's same for XE. So XE theta 1 is alpha E plus beta E times theta, and XE theta 0 is alpha E plus beta E over 2 times theta. And we assume alpha D is smaller than alpha E and beta D is larger than beta E, but the assumption on alpha is not important. I just make that assumption just to draw a nice graphs like this. So assumption on alpha is not important. What is important is the slope. Okay, so xd theta 1 increases at the highest slope, and xd theta 0 is a little bit flatter, and xe is overall flatter than xd, right? So this is the output, depending on theta, which is talent. Depending on the agent's skill, I mean agent's ability, talent, the output is given by this. Okay, so this is the assumption. We assume the output looks like this. So what does this mean? So there are two different jobs, and there, one is difficult job, the other is easy job, and if the talent is high, and if the assigned job is a difficult job, then output will be really high. So if a talented worker is assigned to a difficult job, then the output will be high. But if a unproductive worker is assigned to a difficult job, then output level is very low. And similarly, the output increases in talent. So if the talented worker creates bigger surplus than less productive worker, but if you compare the easy task and difficult task, for difficult task, talent is more important. And also for difficult task, the skill is more important. If the skilled worker is assigned to a difficult task, then the slope is really high. So the output increases very rapidly in theta, but that is not the case for XE. What that means is for easy task, the skill is less important. Okay, so for difficult task, talent is important, skill is important. For easy task, talent and skill are less important. Okay, so that's the assumption. That's the key assumptions. I probably gave too much information really fast, so let me just repeat it. For difficult task, skill and talent are important. For easy task, skill and talent are less important. So that's the key assumptions. All right. And the principal's payoff is x minus w as usual, and the agent's payoff is w minus c times s. C is the cost of skill investment. So if the agent make a skill investment, which means s equals 1, then the agent's payoff will be w minus c. If the agent doesn't make the skill investment, then the agent's payoff will be simply w. And we assume that small c is small enough. So this is for the agent to acquire the skill is socially desirable. So we'll consider the situation where the skill making a skill investment is socially desirable. Otherwise, we don't have to think about this problem seriously. The holder problem makes the skill investment less profitable or the less doable. But if skill investment is socially undesirable in the first place, then we don't have to think about this problem seriously. But if the skill investment is socially desirable, then we'll have to think about how to overcome the holdup problem, right? So that's why we make this assumption that C is small enough, so it is optimal, socially desirable for the agent to make a skill investment. So using backward induction for a given WD and WE and the investment S, we consider the principal's promotion strategy. So in the last stage, the principal decides whether to promote the worker or not. So the decision is made in this way. So the principal will assign the agent to the difficult task, which means that the principal will promote the agent if the following condition holds, which is xd minus wd is larger than xe minus we. So xd minus wd is the profit when promote the worker, and xe minus wd is the profit when not promote the worker. So because xd minus xe increases in theta, that is one of the assumptions, there exists threshold talent theta prime such that for all theta larger than theta prime, P assigns the difficult task to the agent. So there is some theta prime which satisfies this condition. So yeah, theta prime is the threshold level talent, which makes xd minus xe equals to wd minus we. Okay, and more specifically, for each level of skill, let's consider these two different levels of theta, theta star and theta hat. So theta star is the threshold level when the skill level is 1. So if S is 1, then xd minus xe equals wd minus we when theta is theta star. And similarly, if the skill level is 0, in other words, the worker did not make the skill investment, in that case, xd minus xe equals to wd minus we when theta is theta hat. Okay, so graphically, it can be shown like this. So we have these x graphs, right? So we have xd and xe, which are all increasing in a fixed slope, and xd minus xe is wd minus we. Whatever wd minus we is, for some fixed number. So wd and we are already determined in the previous stage. So at this stage, wd minus we is just some given number. So whatever it is, for this given number, we can find the threshold theta, theta star and theta hat, which makes xd minus xe equals to wd minus we. Okay, so you can see that very clearly in this diagram, right? So, and theta star is the threshold when the skill level is 1, and theta hat is the threshold when the skill level is 0. And because of the assumption 2, theta star will be smaller than theta hat. So what it means is it is more profitable to promote a skilled worker than a unskilled one. So what was the assumption? So the assumption was that for difficult job, skill is important and talent is important. So it is more profitable to promote a skilled worker than a unskilled one. And thus, the agent is more likely to be promoted when skilled. So this gives an incentive to make an investment in skill, right? So this is the promotion strategy. So for a given WD minus WE, so that is determined in the previous stage. So for given WD minus WE, uh, depending on the realized value of theta, so the talent is unknown at the beginning, but later theta is observed by both the agent and the principal, and then the principal decides not to promote the worker if theta is smaller than theta star. Okay, so if theta is very small, then there is no promotion. And if theta is between theta star and theta hat, then the principal promotes the worker only when the skill level is 1, right? So if skill level is 1, then the worker is promoted when theta is greater than theta star. But the worker is promoted when skill level is 0 only if theta is very, very large, only if theta is larger than theta hat. So if theta is in between, the worker is promoted only if S is 1. And if theta is very large, then the worker will be promoted anyway, because for a difficult job, talent is important. And if it turns out that the worker is really talented, then the principal will promote the worker to generate greater output. Okay. So that's the promotion strategy. And now we move backward, we move upward, and to consider the agent's skill acquisition decision. And so the agent's skill investment decision is made by this criterion. So even the assumption is that even the agent does not know theta when deciding whether to acquire the skill or not. Therefore, the agent acquires the skill, the job-specific skill, if the following condition holds. So the left-hand side is the expected wage when make an investment. So what is the expected wage? Expected utility. Expected utility is W minus C. What is W? W is WE, so that's the baseline wage. So no matter what, you will get at least WE. So WE is the baseline wage. No matter what, you will get WE. And if you're promoted, then you will get additional wage, which is WD minus WE. Okay? And because you because you make an investment, you have to bear that investment cost C. So that's the left hand side. So left hand side is the expected utility when make an investment, and the right hand side is the expected utility when you do not make an investment. So again, similarly, WE is the baseline wage, which is the wage that you get no matter what. And if you're promoted, then you'll get additional wage, which is WD minus WE. And the probability that you will be promoted differ in these two situations. If S is 1, then you will be promoted if theta is greater than theta star. And if, there is a typo here. So if S is 0, then you'll be promoted if the probability, if the theta is greater than theta hat. So there is typo here. So the promotion probability differs across the situations. If S equals 1, then you'll be promoted with probability that theta is greater than theta hat. And if S is 0, then you'll be promoted if theta is greater than theta hat. So the inequality can be written like this. So let's look at the expression at the at the second last line. In the second last line, we have this equation, which is basically same with the inequality that we saw in the, let's say, fourth line. So on the left hand side, we have the expected utility when the agent make an investment, and on the right hand side, we have the expected utility when the agent does not make the investment. And because we have WE on both sides, we can eliminate them, and we can further simplify the expressions to get the expression or the inequality at the bottom. So on the left hand side, we have the marginal benefit of making investment, and on the right hand side, we have the cost of making an investment. If the benefit is larger than the cost, then you make an investment. Right? So what is the benefit? Benefit is that you get additional wage, WD minus WE, with probability that theta is in between theta star and theta hat. So that is the benefit of making an investment. So if theta is between theta star and theta hat, you will be promoted only if you make an investment, only if you are skilled, right? So the additional benefit of making an investment is the probability that theta is between theta star and theta hat times WD minus WE, which is the additional wage. So that's the benefit, and on the right hand side we have the cost, investment cost. Okay, so this is the condition for making an for the worker to make an investment. So this is the third stage problem, and then we move backward, we move upward to see the participation decision of the agent. So the participation constraint looks like this. So the expected utility when making an investment is written on the left hand side. So WE plus WE is the baseline wage. So WE plus the probability that you are promoted when you are skilled times WD minus WE, which is the additional wage, minus C is greater than the reservation utility U on the bar. And as before, the IR constraint must be binding. The argument is pretty much the same. So if IR constraint, so the argument goes like this. So if the IR constraint is not binding, then the principal can always improve the profit by reducing wage slightly without violating the IR constraint, which means at the optimal contract, the IR constraint must be binding. So the this participation constraint can be written like the expression in the middle, right? So WE plus probability that theta is greater than theta star times WD minus WE minus C is greater than U on the bar. So we have the participation constraint, and we have the incentive constraint. We just saw that in the previous slide. So we derived incentive compatibility constraint, and we have the individual rationality constraint, and then we can probably derive the optimal wage, WD and WE. And I will claim that the optimal wages are characterized by the binding IC and IR constraint. So what does that mean? So it means that we don't have to maximize anything further. So the binding IC and IR constraint are the two equations, and we have two unknowns, WD and WE, so we can just solve it, right? So that just constructs a system of equations. So two unknowns, two equations, so we cannot add any more equations on that. So if you try to add any more equation, then the system will be overdetermined, so we cannot solve the system. So we'll just get the optimal wage by solving the two equations which are binding IC and IR constraint. Okay. So then, why is that? Why does them why does they have to why do they have to be why should they be binding? Here is the answer. So let's think about the first best contract. The first best promotion strategy. So the first best promotion strategy of the principle should look like this. So let's look at the diagram on the left hand side. So you may want to promote the worker if theta is greater than theta double star or theta double hat, right? Because theta double star and theta double hat are the points where these two lines cross each other, right? So at theta double star, XD and XE cross each other, right? And at theta double hat, again, XD and XE cross each other. So let's suppose the skill level is 1, so S equals 1. Then you want to promote the worker if theta is greater than theta double star, right? Because if theta is greater than theta double star, XD is larger than XE. So then you may want to just give a difficult job to the worker because this worker is talented enough to generate greater surplus in difficult task than in easy task, right? And if S is 0, then you want to promote the worker if theta is greater than theta double hat. So that's the first best promotion strategy, and the profit will increase as you try to mimic this first best contract as much as possible, right? So what does that mean? It means that you want to reduce WD minus WE. So if WD minus WE is 0, then X star will be same with X double star. And if WD minus WE is 0, then theta hat will be theta double hat. So you want to reduce WD minus WDE as much as possible because you want to mimic first best contract because first best contract will generate a greater profit. But for some reason you cannot reduce WD minus WE. So to reduce WD minus WE as much as possible, you have to make the IC constraint be binding. Okay, that's the reason why the IC constraint is binding. So again, let me rephrase it. So the principle tries to minimize WD minus WE, but the principle cannot make it 0. So the reason is this. So given the skill level, the first best threshold, the first best promotion strategy is to assign difficult task to the agent if XD minus XE is greater than 0. So in other words, if XD is larger than XE, you just give the difficult job to the agent. So that's the optimal strategy. But that is socially optimal, but you don't want to do that because if you promote the worker, then you have to pay higher wage. So because of this additional wage, because of the existence of this additional wage, which is WD minus WE, you do not want to follow this optimal strategy. And to get higher wage, you want to reduce this additional wage, the wage difference, WD minus WE, as much as possible. So theta star is the first best threshold if WD minus WE equals to 0, but you cannot do that. So you want to reduce WD minus WE as much as possible, but you cannot make it 0, so the IC constraint must be binding. So what is the IC constraint? IC constraint is the equation at the bottom. So let's look at the equation at the bottom. So you want to reduce WD minus WE as much as possible. So if WD minus WE is too small, then the left-hand side becomes smaller than the right-hand side. The left-hand side is the benefit of making an investment, and the right-hand side is the cost of making an investment. So if WD minus WE is too small, then the agent will not make an investment. But to improve the efficiency, you want to reduce WD minus WE as much as possible. That's why the IC constraint must be binding. And the reason why the IR constraint must be binding is the argument that is really familiar to us. Okay, so the optimal contract is characterized by the following two equations. So we have two equations and two unknowns, which are WD and WE. So in principle, we can solve this equation, and that will characterize the optimal contract. Okay. So what have we learned from this? We learned that using promotion, the principal can make the agent to invest in firm-specific skills, but the promotion decision is socially inefficient. More specifically, the easy task is assigned to the agent even when it is optimal to assign the difficult task. Intuitively, when difficult task is assigned, a portion of newly generated surplus is given to the agent in the form of the wage difference. Thus, the principal assigns the difficult task to the agent only when the additional surplus is large enough. So if the skill investment decision is contractable, the promotion decision would have been socially optimal, but that was not the case. So we have this inefficiency. All right. So that's basically it. That's the lesson that we can learn from this. So when performance-based contract is not available because performance is not verifiable, or performance or output or the revenue, whatever. So if X is not verifiable, we cannot write a incentive scheme which is based on X. Then we can use a job-specific contract. Job-specific incentive scheme to mitigate the moral hazard problem. In this case, the moral hazard problem is called hold-up problem. To make the agent to invest in relationship-specific skill, you can use this job-specific contract or the job-specific incentive scheme. But this is not perfect, right? So the employer's promotion strategy may be inefficient. Too few promotions are made. Okay, so that's basically it. So this is the last lecture, and again, thanks a lot for participating in this process, entire process, and yeah, thanks a lot. Bye.